Imagine how most people felt the first time they heard that one day man would be able to fly, or that we hope to actually land a man on the moon. Those ideas seemed pretty crazy at the time, but today we know just about anyone can fly in an airplane, and we have astronauts actually living in space. Now what if I told you that one day we would be able to fly in an aircraft that could bend, twist, and maneuver just like a bird? Sound crazy? Well, I spoke with Anna McGowan at the NASA Langley Research Center, who's working to incorporate something called morphing technology into aircraft. And these morphing technologies could turn those crazy ideas into reality.
Morphing is looking at really advanced materials and other technologies that will make airplanes even better than they are today. We got the word morphing actually from the word metamorphosis. The word morph means to change, and we're using a lot of advanced materials and technologies to make airplanes change from one configuration to the other. Our task at NASA Langley is to look 20 years into the future. Some of our challenges are making the airplanes even safer, making them more efficient, meaning you could fly farther on the same tank of fuel, or carry more passengers, for example. And we're working on making airplanes as versatile as a bird is. So we're taking some lessons from nature.
To get aircraft to perform with bird-like agility, first you have to understand how birds fly. Efficient wing design, feathers, and hollow, lightweight bones allow birds to fly better than any man-made machine. By drawing on the inspiration of birds, Langley researchers are hoping to develop technologies that will enable aircraft to perform with bird-like agility. For example, synthetic jets will cover parts of the wing and replicate the effects of feathers. These technologies can alter the airflow over the wings for superior maneuverability. Microspheres will replicate the bird's hollow bones and allow lightweight wings to be manufactured for increased performance and efficiency. Sounds like science fiction, but in fact, these technologies are real.
We make airplanes as efficient as birds by trying to replicate or mimic some of the characteristics birds have. As an example, birds use feathers to control the airflow over the wings. We are doing that by using what are called synthetic jets. Synthetic jets suck in their own air and then pump it out very quickly, creating a fluctuating plume of air. This little plume of air basically simulates what a feather would do. On a bird, the feathers are used to adjust the airflow over the wing of the birds so that the bird flies optimally no matter what the air conditions are outside. Now on an airplane we do the same thing. We put these jets inside the wing of the airplane, and say for example we had a gust of wind coming into the airplane, we would turn on very specific jets at the right time and at the right frequency. And by doing so, then we can adjust the airflow over the wings of the airplane, thereby making the airplane very stable and comfortable and maneuverable at all flight conditions. We also want to be able to mimic the porous inside section of a bird bone, because that porous inside section is lightweight, but it adds extra strength. We do that by using what are called tiny microspheres. We would take these microspheres and actually inject them into a composite material. And once we inject them in, we would use heat to fuse them together. So therefore, we could achieve a lightweight structure that is also very strong, which is the same thing that birds use when they fly.
Anna, besides birds, are there any other designs inspired by nature?
Well, we're also looking to the water for some inspiration from nature. Fish and shark and whales swim very efficiently in the water. And the flow of water over the skin of a shark is very similar to the flow of air over the wings of an airplane. If you look at shark skin under a microscope, you'll actually see a bunch of little teeny grooves. So our hope at NASA Langley is that perhaps our material scientists can create the same groove-like material, and we can apply that to the skin of airplanes and make them much better flyers. We're also looking at flapping wing airplanes, believe it or not. This design was inspired by the wings of a hummingbird. If you use an airplane that does not have flapping wings, you have to have two things, an engine and wings. Flapping wing airplanes do not need an engine. The wings will provide you forward motion or thrust as well as lift, which goes up.
So Anna, tell me how you design a flapping wing without using an engine.
We actually use what are called smart or active materials instead of using an engine.
And why is it referred to as smart material?
Well, smart materials actually move on command. These are materials that when you apply a stimulus, like electricity or heat, or in some case magnetism, they actually move. Another very common one that we've just developed is called a macrofiber composite. The macrofiber composite works by, when you apply electricity to it, it will move in the direction you'd like it to move. So what we would do is when we adhere this, or if you were embedded inside an airplane wing or the tails of a fighter airplane, it would actually absorb the vibration. As a consumer, you can put these in your washing machine to absorb vibration. You can put it in your cars. You can even use it to absorb sound. So we think that these materials like this one are really going to revolutionize how we build things in the future. We're also looking at a material called a shape memory alloy. We would use this material to bend and twist airplane wings. Now, you might wonder why we'd want to do that kind of thing. Well, birds also bend and twist their wings in flight. Now, being able to bend and twist airplane wings is really difficult because airplane wings tend to be very stiff. If you bend this material, the shape memory alloy, it will actually go back to its original shape. So if you bend this, I'll show you what it looks like. Then I'm going to apply this lighter to it, and you can watch it go back to its original shape. Now this simple little material can pull around 700 pounds. So by placing a couple of these in an airplane wing, we can make the airplane bend or twist. We hope that by flying more like a bird does, we can save a lot of money on fuel, as well as reduce the complexity of the mechanisms within the airplane wing. So we're using a lot of these biologically inspired materials and technologies to make aircraft and spacecraft a lot safer to fly.